Hi boys, let's start a new chapter in Indices. We've done this chapter earlier in 7th as well as 8th. So let's just revise a few properties. A to the power m multiplied with a to the power n is equal to a to the power m plus n. That's the first property. The second property is a to the power m divided by a to the power n is equal to a to the power m minus n. Please note that the base is the same in all cases. Let's look at the third one. The third one is a to the power m raised to the power n is equal to a to the power m multiplied with n. Again, notice that the base is the same. Number 4, which is any number to the power 0 is equal to 1. Number 5. This is just a quick revision of what we've already done. A into b raised to the power m is equal to a to the power m into b to the power m. Sixth one, a upon b to the power m is equal to a to the power m upon b to the power m, which means the powers can be separated. Number 7, nth root of a means a to the power 1 upon n. Nth root of a means a to the power 1 upon n. Number 8, a to the power m upon n will mean the denominator goes as the nth root. So nth root of a to the power m. And the last two, number 9. Number 9 says a to the power m is equal to 1 upon a to the power negative m. And then the last one, which is a to the power negative m is equal to 1 upon a to the power m. These are certain properties that we've done earlier. Now let's apply these properties and solve some questions. So I'm on question 1, part 2. Question 1, part 2 says 5 to the power negative 4 multiplied with 125 to the power 5 upon 3 divided by 25 to the power negative half. So the objective is to ensure that all the bases are equal. Now I notice that all bases can be converted into 5. So this is 5 into 5 to the power negative 4 multiplied with 5. 125 can be written as 5 to the power cube raised to the power 5 by 3 divided by 25 to the power negative half. Now let's write this. This will be 5 to the power negative 4 multiplied with 5 to the power 3 into 5 by 3 divided by 25 to the power negative half, which means if I have a negative power, then I can write it in the denominator. So this is 25 to the power half. This becomes 5 to the power negative 4 multiplied with 5, 3 gets cancelled, 5 to the power 5 divided by 1 upon 5 square. 25 can be written as 5 square and to the power half. This is 5 to the power negative 4 multiplied with 5 to the power 5 divided by 1 upon 5 to the power 2 into half. This gets cancelled. So this is 5 to the power negative 4 multiplied with 5 to the power 5 divided by 5 to the power negative 1. This is in the denominator. So let's apply the property. So a to the power m into a to the power n is addition. So I have 5 to the power negative 4 plus 5. And when I divide, I subtract the power. So which means minus of negative 1, which means 5 to the power negative 4 plus 5 plus 1, which is equal to 5 to the power 2, which means 25. So that's my answer. Let's move on to the next question. Question number 1, part 4. 7 to the power 0 multiplied with 25 to the power negative 3 by 2 minus 5 to the power negative 3. So 7 to the power 0 any number to the power 0 is 1. So 1 multiplied with 25 can be written as 5 square multiplied with the power which is negative 3 by 2 minus 5 to the power negative 3. This and this gets cancelled. 1 multiplied with this number means it's the same number. So I have 5 to the power negative 3 minus 5 to the power negative 3, which is equal to 0. So let's move on to the next one. So the next question that we do is question number 1 part 5. So let's write the question. Question 1 part 5. Question 1 part 5 is 16 upon 81 to the power negative 3 by 4 multiplied with 49 upon 9 to the power 3 by 2 divided by 343 upon 216 to the power 2 by 3. So let's try and convert everything into a common base. So I noticed that in this for the first one the common base can be 2 and 3. So 16 can be written as 2 to the power 4 and 81 can be written as 3 to the power 3, 9, 27, 18, 4 again. So this is 2 upon 3 to the power 4 multiplied with negative 3 by 4 because 16 is 2 to the power 4 and 81 is 3 to the power 4 multiplied with 49 can be written as 7 to the power 2. Perfect. So 7 to the power 2 and 9 can be written as 3 to the power 2. So to the power 2 multiplied with 3 by 2 divided by 343. 343 is 7 into 7 into 7, that's 7 cube upon 6 cube into 2 by 3. So 3 and 3 gets cancelled, 2 and 2 gets cancelled, 4 and 4 gets cancelled, and I have 2 to the power negative 3 upon 3 to the power negative 3 multiplied with 7 to the power 3 upon 3 to the power 3 divided by 7 to the power 2, and instead of 6 I will write this as, since I noted that the bases are 2 and 3, I will write 6 as 2 into 3 and the power is 2. So now let's put everything together. So this will be 2 to the power negative 3 upon 3 to the power negative 3 into 7 cube upon 3 cube divided by 7 square upon 2 square into 3 square. So now instead of division sign, let's put multiplication sign so that let's leave it like this only. Let's subtract now. So let's put everything in the numerator so that our life becomes simple. So in the numerator I can write this as 2 to the power negative 3 multiplied with 3 to the power 3, because this is 1 upon 3 to the power negative 3 multiplied with 7 cube multiplied with 3 to the power negative 3 divided by 7 to the power 2 and multiplied with 2 to the power negative 2 multiplied with 3 to the power negative 2. So I have taken everything in the numerator so that it is easier for me to calculate. So let's move to the next one. So now let me take everything in the numerator and then let's see how it works. So 2 to the power negative 3 multiplied with 3 to the power 3 into 7 to the power 3 into 3 to the power negative 3 divided by 2 to the power negative 3 into 3 to the power negative 2 into 7 to the power 2. Now let's put everything together. 2 to the power negative 3, this is divisible, divided by, so this becomes minus of negative 3. This is not 3, this is 2. That's my mistake, sorry. This is not 3, this is 2. This is 2 to the power 2, so here it becomes 2 to the power 2, not 3, my mistake. So let's change this. This becomes 2 to the power negative 2 and this is also 3 to the power negative 2. Perfect. So here also this becomes So this is 2 to the power negative 3 minus 2 to the power negative 2. So this is minus negative 2 multiplied with 3 to the power 3, and this is minus 3, so this is 3 minus 3, and minus of negative 2. This is divisible. Perfect. Multiplied with, so I have taken care of this element, this element, this element. 2 and 3 is also gone, so next is 7. So 7 to the power 3 minus 2. So this is 2 to the power negative 3 plus 2 multiplied with 3 to the power 2. 3 minus 3 is 0. This is plus 2 multiplied with 7. So this is 9, sorry, not 9. This is 2 to the power negative 1 multiplied with 9 multiplied with 7. So 9 into 7, that's 63, and 2 to the power negative 1 is in the denominator. So this is 31.5. That's my final answer. So let's move on to the next question. Next question that we solve is question number 2, part 1. So let's solve this question. Question 2, part 1 is 8x cubed divided by 125y cubed raised to the power 2 by 3. We need to simplify this. So I can write 8x cubed as 2x whole cube divided by 5y whole cube. 2x whole cube is 8x cube, 5y whole cube is 125y cube. So this is this, and in the power is 2 upon 3. So this is 2x upon 5y cube multiplied with 2 to the power 3. 3 and 3 get cancelled. So my answer is 2x upon 5y whole square. Let's open this bracket. This will be 4x square upon 25y square. So let's move on to the next question. The next question that we'll solve is question number 2, part 3. Let's try and solve that question. Question 2, part 3. So it's 3x square to the power negative 3 multiplied with x to the power 9 to the power 2 upon 3. So then this is in the denominator because this is negative power, which means it moves to the denominator. So this is 1 upon 3x square to the power 3 multiplied with x to the power 9 can be written as x cubed into 2 to the power 3. This gets cancelled. So I have x to the power 3 to the power 2, that's x to the power 6 upon 27. 3 to the power 3 is 27, and this is x squared to the power 3 is also x to the power 6. So x to the power 6 and x to the power 6 gets cancelled. So my answer is 1 upon 27. Let's move on to the next question. The next question that we solve is question number 3, part 1. So let's move on to the question 3, part 1. So question 3, part 1 is 1 upon root 4, or root 1 upon 4 rather. So root 1 upon 4 plus 0.01 to the power negative half minus 27 to the power 2 upon 3. So let's try and solve this. Let's see what we can do. 1 upon 4, so the square root of 1 is 1 and square root of 4 is 2. So that's 1 upon 2. 0.01 can be written as 1 upon 100. Yes, it can be written as 1 upon 100 raised to the power negative half minus 27 can be written as 3 to the power 3. 3 into 3 is 9, 9 into 3 is 27. 3 cubed raised to the power 2 upon 3. So let's see what can be done. So this is half plus, this can be written as 1 upon 10 whole square raised to the power negative half. Perfect. Minus 3 to the power 3 into 2 by 3. 3 and 3 gets cancelled, 2 and 2 gets cancelled. What I am left with is half plus 1 upon 10 to the power minus 1 Perfect, because 1 upon so this is minus 3 square. This is half plus, if the power is denominator in negative in the denominator, it moves to the numerator. That's plus 10 minus 9. So this is 10 minus 9, that's 1. So that's 1.5. That's it. So let's move on to the next question. Question number 4, part 2. Let's start. Question 4. The one that we do is question 4, part 2. Perfect. Question 4, part 2 is 27 to the power negative 3 upon 9 to the power negative 3, everything raised to the power 1 upon 5. So let's see what can be done. So I can write this as so if this is negative power, it moves on to the top, so this becomes 9 cubed, and this comes in the denominator, so that's 27 cubed raised to the power 1 upon 5. 9 can be written as 3 square, this is to the power 3, and 27 can be written as 3 cubed, and this is to the power 3, and everything is to the power 1 upon 5. Perfect. So then this is let's see, this is 3 to the power 6 upon 3 to the power 9 raised to the power 1 upon 5. So this is divided by, which means I will subtract the power 3 to the power 6 minus 9 to the power 1 upon 5. This is 3 to the power negative 3 to the power 1 upon 5, which means 3 to the power negative 3 into 1 upon 5, which is 3 to the power negative 3 upon 5. Is there some mistake? No, this seems to be fine. This can also be written as 1 upon 3 to the power 3 upon 5. Perfect. So let's move on to the next question. The next 1 upon 3 to the power 3 upon 5. Let's move on to the next question. Question number 4, part 4. You can put a small star on this question. 1 minus 1 minus 1 minus n to the power negative 1 bracket close to the power negative 1 bracket close to the power negative 1. So many brackets, we will apply BODMAS and see which bracket to open. So this is the smallest bracket, so this is what we'll try and open first. So 1 minus when I have a negative power, which means that it moves into the denominator. So 1 minus 1 upon 1 minus n. This bracket closes, negative 1 and everything to the power negative 1. Let's take the LCM and add the, in fact subtract this. So this is 1 minus n minus 1 upon 1 minus n to the power negative 1, everything to the power negative 1. 1 and negative 1 gets cancelled. So I have 1 minus negative n upon 1 minus n to the power negative 1, everything to the power negative 1. So I have opened my first negative power. Let's try and open the second negative power now. So if I open the second negative power, what I will have is 1 minus, again the numerator becomes denominator and the denominator becomes numerator. So 1 minus n goes in the numerator and negative n comes in the denominator. Perfect. I have removed this negative 1, so I am left with the last negative 1. Now I notice there are two negatives together, one negative here, one negative here. So what will happen? This will become positive. So this will become 1 plus 1 minus n upon n, everything to the power negative 1. I've just removed, so this is negative and negative gets cancelled, becomes positive. I'll take the LCM and add. So this is n plus 1 minus n upon n to the power negative 1. So negative n and plus n gets cancelled, and I have 1 upon n to the power negative 1, which basically is equal to n. You can put a small star on this question. That's about it. Let's move on to question number 5. So let's do question number 5. Question 5 says, if 2160 is equal to 2160 is equal to 2 to the power a multiplied with 3 to the power b multiplied with 5 to the power c, find ABC. So let's do the prime factorization of 2160. So let's start. 2160 prime factorization. That's 21080, 2540, 227, 270, 135. Yes, that's correct. 3, that's 4 and 5, 3, that's 15, 1 more 3, that's 5 and 5, that's 1. So let's see how many 2's do we have. 1, 2, 3, 4. 4 2's, 3 3's and 1 5. So then this can be written as 2 to the power 4, 3 to the power 3, 5 to the power 1. So this is 2160, which is they're writing it as 2 to the power a, 3 to the power b, 5 to the power c. Let's, on comparing the powers, we get a is equal to 4, b is equal to 3 and c is equal to 1. Now this is a typical question which will have a tail question. Let's see. Hence calculate the value of 3 to the power a. So they want us to calculate 3 to the power a multiplied with 2 to the power negative b multiplied with 5 to the power negative c. So let's replace the value. So 3 to the power a is 4 multiplied with 2 to the power negative b, that's negative 3 multiplied with 5 to the power negative c, which is negative 1. So let's take things in the numerator and denominator. So 3 to the power 4, that's 9 and 9, 81 upon 2 cubed, that's 8 into 4, that's 81 upon 40. We need to write it in the simplest form. So that's 2, 1 upon 40. That's my final answer. Let's do one more question. Question number 7, part 1. Let's start question 7, part 1. Question 7 says 8 to the power 3a multiplied with 2 to the power 5 multiplied with 2 to the power 2a divided by 4 into 2 to the power 11a multiplied with 2 to the power negative 2a. I notice that everything can be written in the form of 2. So let's start everything in the form of 2. 8 is 2 to the power 3 to the power 3a multiplied with 2 to the power 5 multiplied with 2 to the power 2a. This is 2 square. This is 2 to the power 11a. This is 2 to the power negative 2a. So this is 2 to the power 9a, 2 to the power 5, 2 to the power 2a, 2 to the power 2, 2 to the power 11a, 2 to the power negative 2a. Let's add 2 to the power 9a plus 2a plus 5, and in the denominator is 2 to the power 11a minus 2a plus 2. So this becomes 9a plus 2a, that's 2 to the power 11a plus 5 upon 2 to the power 11a minus 2a, that's 9a plus 2. This is division, so we will subtract the power. So that's 2 to the power 11a plus 5 minus 9a plus 2. Remember, we are subtracting both these powers. So this is 2 to the power 11a minus 9a plus 5 minus 2, which is 2 to the power 2a plus 3. So that's my final answer. Let's move on and let's solve question number 7, part 2. And you can put a small star on this question. Requires a new trick. We haven't used this yet. at least not in this chapter. 3 into 27 to the power n plus 1 plus 9 into 3 to the power 3n minus 1 upon 8 into 3 to the power 3n minus 5 into 27 to the power n. Now I noticed that in this question there are different powers. One power is, as in one base is 3, 27 can be converted into 3. This is again 3 and 3. This is 2, this is 3, this is 5, this is 3. So I have 3, 2, 5. Too many powers, or rather too many bases. Let's see if there's something common that we can take out. So let's see. Let's first write it in the simplest form. So that 3 into 27 can be written as 3 cubed to the power n plus 1 plus 9 can be written as 3 square multiplied with 3 to the power 3n multiplied with 3 to the power negative 1. I am removing changing this into 3 to the power 3n into 3 to the power negative 1. Why? Because I noticed that 3 to the power 3n seems to be common between these two elements on the numerator. Let's see how it works. And 8 into 3 to the power 3n minus 5 into, this can be written as 3 to the power cube raised to the power n. So now let's open these brackets. So I have 3 into, this can be written as 3 to the power 3n plus 3. Yes, it can be written as 3 to the power 3n plus 3, and this is in plus 3 square. And if I take these two together, this is 3 to the power 2 minus 1 multiplied with 3 to the power 3n upon 8 into 3 to the power 3n minus 5 into 3 to the power 3n. Let's see. So this is 3 into, again I notice that there is 3n in this denominator term 1, denominator term 2. Again in numerator I have 3 to the power 3n, and again I can change this to 3 to the power 3n. So let me just convert this. 3 into 3 to the power 3n multiplied with 3 to the power 3. Perfect. Plus 3 to the power 2 minus 1 is 3 multiplied with 3 to the power 3n. And in the denominator I notice that 3 to the power 3n is common. So let me take 3 to the power 3n common, and what I am left with in the first term is 8, and what I am left with in the second term is 5. So then this is 3 to the power 3n multiplied with 3 into 3 to the power 3 become 3 to the power 4 plus 3 into 3 to the power 3n upon 3 to the power 3n 8 minus 5. Oh, I can, in fact I know what 8 minus 5 is. Let me just put this as 3. Perfect. So again in the numerator I notice 3 to the power 3n is common. What I am left here is 3 to the power 4 plus what I am left here is 3 upon 3 to the power 3n multiplied with 3. This and this gets cancelled, so n is gone. Makes my life simple. That makes it 3 to the power 4. That 9 into 9, 81 plus 3 upon 3. That's 84 upon 3, which is equal to 28. My final answer is 28. Perfect. So let's move on to the next question. The next question is question number 8. Let's start question number 8. Question number 8 says, show that something to the power something is equal to 1. So let's start working with left hand side. I've already shared with you that if you're working, you need to prove left hand side equals equal right hand side. Either you start with left hand side or with right hand side. So let's start with left hand side in this question. So a to the power m upon a to the power negative n to the power m minus n multiplied with a to the power n upon a to the power negative l raised to the power n minus l multiplied with a to the power l upon a to the power negative n to the power l minus m. That's my left hand side. I notice that all the bases are equal, so let me just put everything in the numerator. So this becomes a to the power m minus of negative n, which is plus n, and this is to the power m minus n. Similarly, this becomes n plus L to the power n minus L. And this becomes a to the power L plus m to the power L minus m. Now this looks like a to the power m to the power n, which is m into n. So in this case, a to the power m plus n multiplied with m minus n multiplied with a to the power n plus L multiplied with n minus L multiplied with a to the power L plus m multiplied with L minus m. Now this is x plus y into x minus y. How much is that? Yes, x square minus y square. In this case, m square minus n square. In this case, it will be n square minus L square. And here it will be L square minus m square. Now the bases again are equal, so let me just add the powers. So it will be a to the power m square minus n square plus n square minus L square plus L square minus m square. Negative m square, negative n square, and negative L square, L square. So what I am left with in the power is 0, a to the power 0, which is equal to 1, which is my right hand side. So hence proved. So let's move on to the last question that I want to solve from this exercise. Question number 10, part 1. So let's start. Question 10, part 1. Question 10, part 1 is x to the power a upon x to the power b to the power a square plus ab plus b square multiplied with x to the power b upon x to the power c raised to the power b square plus bc plus c square multiplied with x to the power c upon x to the power ca, everything to the power c square plus ca plus a square. Now I notice everything has the base x, so let me take everything in the numerator and see how it works. So this is x to the power a divided, which means minus a minus b, and this is getting multiplied with a square plus ab plus b square. Here this becomes x to the power b minus c multiplied with b square plus bc plus c square. And here this is x to the power c minus a multiplied with c square plus ca plus a square. Now if I remember my expansions properly, a minus b into a square plus ab plus b square is equal to a cube minus b cube. So this is x to the power a cube minus b cube multiplied with x to the power b cube minus c cube multiplied with x to the power c cube minus a cube. Since the powers of the bases are the same, let me add the powers. So a cube minus b cube plus b cube minus c cube plus c cube minus a cube. So negative a cube and a cube get cancelled, negative b cube and negative c cube gets cancelled. I am left with power 0, which means anything to the power 0 is 1. So that's my final answer. Now let's write the homework questions for you. Homework. So question number 1, part 1. Question number 1, part 3. Question number 2, part 2. Question number 3, part 2. Question 4, part 1, part 3. Question number 6. Question 7, I solved both the parts. Question 8, there's only one. Question 9. And question 10. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's enough homework for you. Thank you so much. Bye bye. Take care.